Hi everyone, welcome back. Today we're going to be looking at day 2 of section 3.7, which is solving absolute value inequalities. For today, again, you're going to need a notebook and a pencil to take notes, and our learning objective is that students will be able to solve an inequality with absolute value using compound inequalities. So we're going to have to think back to everything we learned in 3.6 to help us solve some inequalities today in 3.7. So let's get started. The first type of inequality that we're going to be looking at is less than. So, to solve an absolute value inequality in the form of the absolute value of A is less than B, we have to solve the inequality of negative B is less than A, which is less than B. Then graph the solutions. Keep in mind, we have to isolate their variable expression before we put it into that AND statement. So let's do some practicing. If you notice on the left-hand side, we have the absolute value of x plus 3 is less than 5. The absolute value expression is already isolated, so we can go ahead and write it as an AND inequality. So if I write this as an AND inequality here, we are going to have negative 5 is less than x plus 3, which is less than 5. And if you remember, when we're solving AND inequalities, we are going to write two inequalities based off what we're given. So I'm going to write an inequality based off this first half here. So negative 5 is less than x plus 3. And I'm going to write one based off the second half here. So x plus 3 is less than 5. Then I can solve for both of them. I'm going to draw my line down my inequality. And in this case, the steps to solving is exactly the same. I'm going to subtract 3 on both sides. 3's will cancel out. And then I get negative 8 is less than x. And I also get that x is less than 2. I can bring those back together and write them as a compound inequality of negative 8 is less than x, which is less than positive 2. Then, because we're dealing with inequalities, we can graph this. So on my number line, I would have a negative 8 and a positive 2. 0 is roughly there. And then I would have open circles on both values, and I would connect them with a line in the middle. There we go. There's our answer to our absolute value inequality. Let's try another one. So for this one, it might be a little bit difficult to tell, but the division of 5 here is not in the absolute value sign. It's actually on the outside. So before we solve for this one, we have to isolate that variable expression by multiplying by 5. 5's cancel out, and we are left with 2x, where the absolute value of 2x plus 4 is less than or equal to 5. Now this is an AND statement, so we are going to, or this is a less than, so we're going to write this as an AND statement, which will give us negative 5 is less than or equal to 2x plus 4, which is less than or equal to 5. And again, I'm going to solve for each half. Okay, so I'm going to run out a little bit of space. I'm actually going to shrink this down a little bit, if it lets me. And it's not going to, so we're just going to have to deal. Sorry. Okay, so I'm going to have negative 5 is less than or equal to 2x plus 4. And then I also have 2x plus 4 is less than or equal to 5. Draw my lines. I'm going to start by subtracting 4. My 4's cancel, and I get negative 9 is equal to 2x, or I'm sorry, is less than or equal to 2x, and I get 2x is less than or equal to 1. On both sides, I'm going to divide by 2. The 2's cancel out as well. And then when I go to write this as a compound inequality, we are going to have negative 9 halves is less than or equal to x, which is less than or equal to 1/2. And that is our answer for that. So again, I'm going to graph this. This is going to be an and inequality on our graph. So I'm going to have negative 9/2 on the left, roughly 0 is here, and then my 1/2. Okay, we're going to have closed circles this time. So that's pretty much the biggest difference compared to the other graph, is that we have closed circles. And again, they're going to be connected in the middle. And there we go. There is our graph and our solutions to this one. Okay. The next type of inequality we're going to look at is greater than. So this one's a little bit different. To solve an absolute value inequality in the form of absolute value of A is greater than B, we have to solve the compound inequality A greater than B or A less than negative B, and then graph the solutions. For this one, it's really important to remember that if you're given the greater, right, the greater one, our first inequality is always going to look very similar to this one. So notice A and B in this case are positive. A and B, when we go to write it here, is going to be positive as well, okay? Sometimes students kind of mix up like, oh, which one's going to be greater, which one's going to be less than, which one has the positive number, which one has the negative. So it should always match, the greater should always match the greater in the first inequality. Okay, so let's actually try one of these. The first one we have is 8, the absolute value of 8x is greater than 24. Variable expression is isolated, so we're going to write our two inequalities. My first one is going to match what we're given, right? I'm given 8x is greater than 24. So that's going to be what I write, or equal to. My second one, that's when we change it. I'm going to have 8x, and now it's going to be less than or equal to negative 24. So when we make our b value negative, we flip the sign, okay? In both cases, we're going to solve exactly the same by dividing by 8. Okay, 8's cancel, and x is greater than or equal to 3, and then x is less than or equal to negative 3. And remember, when we go to write our final answer, we have to write it with an or. So I would put x is greater than or equal to 3, or x is less than or equal to negative 3. And then we can graph these. I'm going to have 0 in the middle, negative 3 on the left, positive 3 on the right. They are both closed circles, and because this is an or statement, my arrows point out away from each other. And there we go. That is our answer for that one. Okay, the second one here, again, another example where we have to move something before we write our two inequalities. So I am going to add 3 on both sides. 3's cancel, and I'm left with the absolute value of negative 5x plus 1 is greater than 24. Because greater than, we're going to have an or statement. Again, my first one is going to look very similar, but without the absolute value signs. So negative 5x plus 1 is greater than 24. Then the second one is going to be negative 5x plus 1. Flip the sign to less than, adding negative sign in front of our 24. Draw our line down each inequality, and now we're going to solve. For both, we're going to subtract 1. 1's cancel. We get left with negative 5x is greater than 23. I don't know why I accidentally canceled it out on the left. That was a mistake on my part. I'm supposed to cancel out over there. And then we're left with negative 5x is less than negative 25. Then we're going to divide both sides by negative 5. And on this side, we have x, sign flips to less than 23 over negative 5. And then on the other side, when we divide by negative 5, again, sign flips, so we get x is greater than, and that gives us a positive 5. So when we go to write our final answer, I'm going to have it as, I'll write it down on the bottom here. X is less than 23 over negative 5, or X is greater than 5. So on my number line, I'll have my 5, my 0 is going to be closer on this side, and then my negative 23 over 5. Both of them are going to have open circles, and they will be pointing outward. Let me fix that line. And there we go. There's our answers for that one. Now you might be thinking, Mrs. Latham, how am I supposed to remember if it's an and or an or? And so I've kind of come up with this really cheesy, kind of obvious little trick that I'd like to share with you guys. So for less than, it's always going to be an and. So it's kind of like a play on words. Less than is what we're going to call it. And we're always going to use an and statement. Then for greater, again, another play on words, it's going to be greater, or, right? So we're going to use an or for that one. Now, if you're looking at the left, you're probably thinking, but you wrote a greater than symbol. But keep in mind, like what we just noticed in that last problem, negative signs flip our inequality. So just because that looks like it's a greater than symbol and you might be compelled to make it an or, it might turn into something else, like an and. So let's look at this one first. And I know I'm going to write big, so I'm going to run out of space. So I'm going to try to write tiny here. We're going to start off with subtracting 5 on both sides because we have to isolate our variable expression. We get left with negative 10 times the absolute value of 8n minus 10, which is greater than negative 60. Now we have to divide everything by negative 10. And what ends up happening is we get the absolute value of 8n minus 10 is less than, sign flipped, right? Dividing by a negative, and then it becomes a positive 6. So b is greater than 0, so we can solve, and our sign flips. So now this is a less than symbol, so we're going to use an and. So we are going to have that negative 6 is less than 8n minus 10, which is less than 6. And we're going to have our two inequalities. So negative 6 is less than 8n minus 10, and 8n minus 10 is less than 6. For both of these, we are going to add 10. Negative 6 plus 10 gives us a positive 4, which is less than 8n, and then 8n, which is less than 16. Divide both sides by 8, and we are going to get the compound inequality of 1/2 is less than n, which is less than 2. And that is our answer. Again, we can graph this. I'm going to have my 1/2. I'm going to have 1 here. This is going to be 3/2. This will be 2. So this one we can actually count up by halves to graph. And if you hear squeaking in the background, that's my dogs, and I apologize. Okay, so we have less than symbols, not equal to. So it's going to be open circles, and then they'll be pointing inward towards each other. And there we go. That's our graph for that one. Now for this one here, we do have a greater than or equal to symbol, and it's under the section greater, so the sign will not be flipping, but we do still have to isolate our variable. So in this case, keep in mind, we cannot do 9 plus 10 first. We have to subtract the 9 and then divide by 10. So that's what I'm going to do here. Subtract 9. We get 10 times the absolute value of 1 plus 4r is greater than or equal to 10. Divide by 10, and we get the absolute value of 1 plus 4r is greater than or equal to 1. So again, this is an or, so we have to write our two or statements. So again, the first one's going to match almost identical to what we're given, just without the absolute value sign. So 1 plus for r is greater than or equal to 1. Then the second one flips the inequality and we add a negative to our 1. So we will have 1 plus 4r is less than or equal to, and then our negative 1. Draw our line. We are going to subtract 1 first. That gives us 4r is greater than or equal to 0. And if I do it again on the other side, we get that 4r is less than or equal to negative 2. On the left, we're going to divide by 4, and we get that r is greater than or equal to 0. On the other side, we get our or, r is less than, that's a crappy less than symbol, so we're going to change that. So r is less than or equal to our negative 1/2. And again, that is our answer there. So to graph this, I'm going to have 0 right on the left there. I'm going to have my negative 1/2, negative 1, negative 3/2. I'll have positive 1/2 on the right. They're both going to be closed circles. And then we're going to have arrows pointing out from each other. And there we go. There is our graph and solution to our greater than symbol or absolute value. If you have any questions, please reach out. Otherwise, that is it for today's lesson, and I hope you guys have a great rest of your day. Bye, guys.